In this lesson, we're going to look at the definitions of our trigonometric functions or trigonometric ratios. And so what we have here is we've got an angle drawn in standard position. We have our angle of rotation, which we've called theta. Now, our definitions are based upon a point. So what we want to do is to take a point and on our terminal side of our angle, and we're going to drop a perpendicular down to the x-axis so that we've got us a right triangle. Now the point we can label as xy. So that this is any point, not a particular point. And we have a point then on our terminal side. We also need to know the distance from the origin to the point, which is called r. Most of our trigonometry is actually based upon circles, and so that's usually called r for the radius. And to do that, to find out what r is, we can use our distance formula, because this x is the distance from our origin to this point, and y is the distance from our point to our x-axis. And so this distance is our y, and this distance is our x, whatever that value is. And we know that x squared plus y squared equals r squared. Now usually when we write the distance formula, we wrote that r was equal to the square root of x squared plus y squared. So let's simply take the square root of both sides. So the square root of x squared plus y squared is equal to r squared. Excuse me, is equal to r. Let me erase that. And so this is our formula then for finding r. Now, our definitions of our trig functions then are based upon our points of x, y, and r. We define the sine of an angle, and sine is actually spelled S-I-N-E, but we abbreviate it S-I-N, is defined to be y over r. The cosine of an angle, which we abbreviate COS, is defined to be x over r. The tangent of the angle is defined to be y over x. Then we have the cosecant of the angle is the reciprocal. It's defined to be r over y. The secant is the reciprocal of the cosine, and it's defined to be r over x. And the cotangent is the reciprocal of cotangent, x over y. Now these are the definitions for your 6 trigonometric functions, and you need to know these. You need to know them by memory. They're based upon a point. We'll also define them later on for a right triangle, and we'll define them a little bit differently, probably a way that you're more familiar with. But this is how they're defined based upon a point. And this is a definition we'll use quite a bit. So you need to memorize these definitions. And there's things that you can do to help if you memorize your sine, cosine, and tangent, and you know which one's the reciprocal, which will actually be defined later, then there's not as much memory to do. And so you're not having to do a lot of sheer memory. Now, different ways that you can know which ones are reciprocals as far as the names go. The way I learned it and memorized it was with each pair, there was always a C. So if it was sine, then its reciprocal had to be cosecant. If it's cosine, there's your C, so its reciprocal had to be secant. Tangent, it had to be cotangent. And we'll look at later on why they're named in the form that they are. But you do need to know your 6 trigonometric functions and how you go about defining them based upon a point. Now what we want to look at next is how we use a point to find these 6 functions. So we want to find our 6 functions of an angle that was in standard position. So let's draw an angle in standard position. We have our coordinate plane. And in this case, we're going to use the point 3, -5. So we're drawing the angle all the way around to the 4th quadrant. And a point on the edge, or on our terminal side, is the point 3, -5. And this is our theta. So what we want to do is we want to find r. Well, r, we know, is equal to the square root of x, which is 3 squared, plus y squared. So that's going to be the square root of 9 plus 25, which is the square root of 34. Now we can't simplify the square root of 34, so we will leave it. R will always be positive. X and Y can be positive or negative depending upon the quadrant, but R will always be positive. So according then to our definition, the sine of theta is equal to Y over R. Now, according to different textbooks, some textbooks have you rationalize the denominator, some don't. So what you need to do is to look at your text to see did they rationalize or did they leave it in radical form, and also whatever your instructor has you do. If we rationalize this, we'd multiply both the numerator and denominator by the square root of 34. So we would end up with -5 square roots of 34 over 34. The cosine of theta is x, which is 3 over r. And again, if you rationalize that, you'd end up with 3 square roots of 34 over 34. The tangent is y over x. Okay, the cosecant is r. Now, if you're looking back here, you can look at your definition. It's r square root of 34 over y, which was -5. Normally, we don't write a negative in the denominator. We'll put the negative out in front of our fraction. The secant is r, the square root of 34 over x, which was 3. And the cotangent is -3 over 5. The whole function is negative because the 5 was negative, but we don't normally put a negative in the denominator. So now we have our 6 trigonometric functions defined for an angle who has on its terminal side the point 3, -5. And so this is how you can define your functions based upon a point. Let's look at it a little differently. Instead of having a point that we're given, we're going to look at an angle. And we want to find the sine and cosine of 120 degrees. We want to find the sine of 120 degrees. And we want to find the cosine of 120 degrees. So we draw our angle in standard position. We've rotated around 120 degrees. And we want to find our functions. We want to find the sine and the cosine for this. Well, the problem is the only way we know how to find the sine or cosine is with a point. So we need a point on our terminal side. Well, if we pick a point and we go down to our axis, then we're going to need the coordinates for that point. One thing you might notice is if we rotated 120 degrees around and then we went down to our x-axis, then that means this angle from our terminal side to our x-axis is 60 degrees. 180 minus 120 would be 60 degrees. Well, we know the ratio for the sides of a 60-degree angle. We know the side opposite the 60 degree, which in this case would correspond to our y, is the short side times the square root of 3. So let's let our short side be 1. And in this case, since we're on the negative x-axis, that would be negative 1. But our y would still be the square root of 3 because the y-axis is positive in the second quadrant. So those ratios are based upon just a triangle and not in a particular quadrant. So we've got those ratios, and then that means that our hypotenuse, which is r, is twice the short side, so it's going to be 2. So we have our x and our y, and if you wanted to write that as an ordered pair, our x is negative 1, our y is the square root of 3, and r is 2. So the sine is y over r, so it's going to be the square root of 3 over 2. The cosine is x, which is negative 1 over r, which is 2. So we can find our functions for a particular angle if we can find a point on the edge of that, on that terminal side. Then we can still go through. Later on, we will actually memorize our values for sine and cosine. And this is going to be true no matter what point. We could have picked any ratio that we wanted, and we'll actually look at that just a little bit. Well, let's go ahead and look at that now. It didn't matter which points I picked because I was able to pick any point. If I had gone through for my angle over on my terminal side, and I know that this is 60 degrees, I picked 1. I could have picked 2 when I dropped this down. In that case, r would have been 4, and this side would have been 2 square roots of 3. It would have been the short side times the square root of 3. Now, when I went through to do my values, the sine of 120 degrees, because that was the angle that rotated around, was equal to y, 2 square roots of 3 over r, and that will reduce to the square root of 3 over 2. The cosine would be negative 2 over 4, which reduces to negative 1/2. So we could go through and we could pick any point. In fact, we could have even said that we're just going to call this x. And so our r then would be 2x because it's twice that. These are those ratios that we put in. And our y would be x square root of 3. So if we did our sine of 120, that would have been y, which was x over the square root of 3, or x squared of 3 over 2x. The x's would cancel, and we would have had the square root of 3 over 2. The cosine would have been negative x because we're on the negative side of our x-axis over 2x. The x's would cancel and we have negative 1/2. So it doesn't matter when you're picking this point on the terminal side for an angle. You can pick any point. The ratios turn out to be the same because your sides are always proportional. And so you can pick any point there that you would like to. All right, let's look at another angle. Let's find our functions for 180 degrees. So if we draw our angle in standard position, we've rotated around, and when we do, we end up on the negative side of the x-axis. So we're going to pick a point on the terminal side. Now, we can pick any point that we want to, so we can pick any x. We could pick -1, -2. Let's pick -3, but our y is always going to be 0. Our r is the distance from the origin to that point, so in that case, it's going to be 3 also. It's going to be whatever our x is. Or if you wanted to go back to your formula that r is equal to the square root of x squared, which would be 9, plus y squared 0, it's the square root of 9, which is 3. So there's several ways that you can get that. So when we go through and we find our values, the sine of 180 degrees, because that's our angle of rotation, is equal to y over r, which is 0. The cosine of 180 degrees is x over r, so that's -1. The tangent of 180 degrees is y over x, which again is 0. Now if we go and we find the cosecant of 180 degrees, that's r over y. Well, division by 0 is undefined. The secant of 180 degrees is r over x, which would be -1, and the cotangent of 180 degrees is it's going to be -3 over 0. It's our x over y, which would again be undefined. We can't divide by 0. So we can find our functions even if we have what was called a quadrantal angle where it ends up on the quadrant. Later on, there's going to be some special angles that we will then memorize their values because we're going to use them so often, and 180 is one of those. But we'll look at that later as far as actually memorizing it. Now, some of the things that we might have noticed here as far as our angles go is that depending upon the quadrant that we're in will determine what SIGN, what sign our function has. And that's a very important thing, and again, something that you will need to make sure that you learn. So let's just look at those. If we're in the first quadrant, our x is positive and our y is positive. So if we go through, then that means our sine, and r is always positive, so our sine is a positive over a positive, and it's positive. Our cosine is x over r, so it's a positive over a positive. It turns out to always be positive. The tangent is a positive over a positive, so it turns out to always be positive. And I'm not going to go through and do the reciprocal functions because they will a reciprocal always has the same sign. So your cosecant, your secant, and your cotangent are also positive. So in the first quadrant, they're all positive. in the second quadrant, the sign is y over r. Well, in the second quadrant, y is positive, r is positive, so the sign is positive. The cosine is x over r. Well, in the second quadrant, x is negative, y is r is positive, so in the second quadrant, the cosine will always be negative. And then our tangent is y, which is positive, over x, which is negative, so the tangent will be negative. The sine and its reciprocal are positive. All of your other functions are negative. In the third quadrant, well, the sine is y, which is negative, over r, which is positive, so the sine's negative. The cosine is x over r. Well, x is negative in the third quadrant, r's positive, so the cosine turns out to be negative. And the tangent is y, which is negative, over x, which is negative, so the tangent turns out to be a positive. So the tangent's the positive one, all the others are negative. And in the fourth quadrant, the sine is y, negative, over r, positive, so it's negative. The cosine is x, which is positive, over r, which is positive, so it's positive. And then the tangent is y. Well, y is negative in the fourth quadrant, and x is positive, so it turns out to be a negative. And again, the reciprocals have those same values. So what we need to do is to know when we're in specific quadrants whether we're positive or negative, and that's going to matter. There's several different ways that you can learn this. I learned it one way when I was in learning this. You might notice that in the first quadrant, they're all positive. Some of you can just learn by sheer memory. Some of us need some little helps. In the first quadrant, they're all positive. In the second quadrant, the sign and its reciprocal is positive. And I always found if I knew which one was positive, then all the rest had to be negative. In the third quadrant, the tangent and its reciprocal. And then in the fourth quadrant, the cosine and its reciprocal were the positive ones. So what my teacher pointed out is if you went clockwise and just took the first letters, that was spelled A-C-T-S, ax. And so that's how I learned to remember it. But one year I had a student that went around and said, but we always go counterclockwise. So he said, we are a smart trig class. So you can use a little tool to help you remember, but you do need to know in each quadrant which functions are positive and which ones are negative. This gives you the positive ones, and then the others are negative. And I only put down the main function, not its reciprocal. So let's look then at how we would use that as we go through and we work with some of our functions. Let's say that we're told that the sine is, the sine of the angle is equal to 12/13, and that theta terminates in, and sometimes you'll see it kind of looks like an E, just saying that it terminates in that quadrant, in quadrant 2. So we have an angle that's coming around and terminating in quadrant 2. And we want to find all of our other functions, given one function. Well, since we're in quadrant 2, the sine was positive. We know automatically that the cosine and the tangent are going to be negative. But we want to find those. Well, given the sine, what we're given is x, or y, and r. we need to know x, y, and r. So we can do it with our functions. Well, we know that r is 13, and we know that y is 12. We need to find our x. Now, some of you may recognize one of your Pythagorean triples. And if you do, that's fine. You can fill it in right away. If you don't, then you could go back that x squared plus y squared equals r squared. So we don't know x. Y is 12 and r is 13 squared. So we have x squared plus 144 equals 169. Then subtracting, we get x squared equals 25. Taking the square root of both sides, we get plus or minus 5. So we have to decide, is it the plus or minus? Well, that's where we're in the second quadrant, so we know that x has to be negative. So x is a negative 5. Now we can go through and find our functions. So the sine of theta is 12/13. The cosine of theta is negative 5/13. The tangent of theta is negative 12/5. We always put our negative out in the front. We don't put a negative down with the denominator. So it was 12 over negative 5, which would be negative 12/5. The cosecant is r over y. The secant is r over x. And again, we'll put the negative out in the front. And the cotangent is x over y. And it's negative. So we're in the second quadrant, so the sine and its reciprocal should be positive. All the other functions should be negative. Okay, let's look at one more of these. And our information can be given to us in many different ways. Let's say that we're given that the cosine of the angle is negative 20/29, and that the sine of the angle is less than 0. Now we've got to figure out what that means. The sine of the angle is negative. Negative numbers are less than 0. So if we stop to think about it, the cosine's negative. Well, we know that the cosine is positive in the first and fourth quadrant. You remember, it was all sine, tangent, cosine. So the cosine's positive in the first and second. That means it's negative in the second and third, first and fourth. I keep saying that wrong. But it's negative in the second and the third. The sine's negative. Well, the sine was positive in the first and second, so it's negative in the second and the fourth. So this is the quadrant that makes those both true. So that means that our angle terminates in the third quadrant. Now, we need to go about and we need to find our r. And we can do that by using our formula. We know that, or we need to find our y. We know the cosine is x, so x is 20 and r is 29. Since we're in the third quadrant, x was negative, so we need to find y. And we know we're in the third quadrant, so we know our y is going to be negative. Well, x squared plus y squared equals r squared. X squared is negative 20. Y squared we don't know. R squared is 29 squared. So we have 400 plus y squared is equal to 841. Subtracting, y squared equals 441. Taking the square root of both sides, y would be plus or minus the square root of 441, which is 21. So plus or minus 21. Well, we're in the third quadrant, so it's the minus. So we have negative 21. Now, this is another Pythagorean triple. It's not one that you see often, like the 5, 12, 13 that we just looked at, you will see quite often. This one, it won't come up an awful lot. Okay, the sine of the angle then is y over r. The cosine of the angle is x over r. And the tangent of the angle is y over x, and a negative divided by a negative is a positive, and you would always want to rewrite that as a positive angle. We're in the third quadrant, so the tangent should be positive, the sine and cosine should be negative. And I'm not going to write out the reciprocal functions for those, but we could figure out what those were. And one last thing that we want to do, we've looked at how to find our 6 functions given a point. We've looked at how to find our other functions given a function of the angle. Given one function, we could find all of the others. The last thing we want to look at is how we could go about finding our functions where we're given an equation along the terminal side. So let's say that our angle terminates along the line y equals negative 3x. And we want to find our other functions. And you might say, well, if we graphed this, just so that we can see what's going on, the equation y equals negative 3x, if we start it, our y-intercept would be 0, 0, and then we would go down 3 to the right 1, down 3 to the right 1, and we could draw our line through there. And it's supposed to be a straight line. Well, if you notice, our line is in quadrant 2 and quadrant 4. So we need to know which one. Did we rotate here and stop at quadrant 2, or did we rotate around to quadrant 4? So you would need to be given that other piece of information. So I'm going to give that to you, and we terminate in quadrant 4. Now, we need an x, a y, and an r. So as we look at this, we're told that y is always negative 3 times x. So if we wanted to get an x and a y, we could make us a table just like we sometimes did to graph. If x is 1, then y is negative 3. If x is 2, y is negative 6. We could keep making points, but we only need one point because we already saw earlier that it didn't matter which point on the terminal side we picked, we always got the same ratio. So I'm going to pick the point 1, negative 3. Then to find my r is equal to the square root of x squared plus y squared. So that's the square root of 1 plus 9, the square root of 10. Now I know x, I know y, and I know r. So I can find my functions. So the sine of theta is y over r. And right now I'm not going to rationalize these. Again, that's kind of up to the textbook that you're using and what your instructor wants you to do. The cosine of theta would be x over r. The tangent of theta would be y over x. Now, right here, we need to look at this. First of all, we need to just write it as a negative function. And then 3 divided by 1 is 3. And you'll always go ahead and reduce it down. You always want to reduce your fractions. And you may want to rationalize your denominators. And let me just go back up and do that. So that would be negative 3 square roots of 10 over 10. You're going to find it's very easy to rationalize these because you're just multiplying by the denominator. So this would end up being the square root of 10 over 10. And if we wanted to, we could go through and find our reciprocal functions. Again, we're in the fourth quadrant, so the sine and tangent were negative, the cosine was positive. So what you needed to have gotten out of this lesson is that memorize your the definitions of your 6 trigonometric functions. You need to, which are these. You need to be able, given a point on the terminal side of your angle, find your r and define all of your functions for that angle. If you're given one of the functions where we know a 30, 60, or 45 so that we could find a point on the edge on the terminal side of that angle, then you can give your other functions. Or given one of your functions and the quadrant that it terminates in, then find your other trigonometric functions. Again, all you're doing is finding your x, your y, and your r, and then also given an equation for a line that's on the terminal side, be able to give your trigonometric functions. And the other concept that you need to make sure that you know is in each quadrant, there's a function that's positive and the rest are negative, and you need to know which ones are positive in the 4 quadrants. So make sure that you memorize that. That's a concept you'll use all the time.